Hello friends. So today we'll be starting with another example on 2-point problem for influence line diagram. 2-point loads 100 kilonewton and 70 kilonewtons with spacing of 2 meters, means 2 meters is the distance between them, crosses a girder of span 15 meters from left to right with 70 kilonewton leading. It means 70 kilonewton is at the front, 100 kilonewton is at the back. Calculate reactions and absolute maximum shear force, bending moment and shear force at section 5 meters from left. Say this is my girder or beam. Mark the distance 5 meters. I have to calculate the distances at 5. So let this distance x is equal to 5 and this is L minus x is equal to 10, and this is overall length L is equal to 15. Now there are 2-point loads and they are crossing from left to right. Say this is 1-point load, this is second point load. Leading 70 kilometers, leading 70 kilometers. It means 70 is at the front, 100 is at the back. Now they are moving from left to right. This is the direction of movement of loads. Now distance between the two is 2 meters. So this is how they are moving. Step 1, ILD for RA, reaction at A. Now let us draw the standard triangles. So standard triangle for RA is this is the standard triangle. Two loads 100 and 70. So 100 is acting here, 70 is acting here. Let this ordinate be 1 unit, this ordinate y1. So distance between them is 2 and this overall is 15. So 15 minus 2 is 13. Now consider two triangles, 1, 2, 3. This is a bigger triangle and this smaller triangle. So for bigger triangle I can write 1 divided by 15 is equal to y1 divided by 13. So I will write 1 divided by 15 is equal to y1 divided by 13, or y1 is equal to 0.867. This is the ordinate value. Now reaction at A is equal to this load into this ordinate plus this load into this ordinate. So this load is 100, this load is 70. So I can write RA is equal to 100 into 1 plus 70 into 0.867. So you have the value 160.69 kilonewtons. Similarly, RA for reactions for ILD for RB. ILD for RB. So we can draw a diagram. These diagrams are standard. This is the diagram. Now put the loads. So here 70 is at the front, 100 is at the back. So 70 has reached B and this is 100. This ordinate is 1, this ordinate is y2. Mark the distances. This is 2 meters. Given distance between them, this is 3 meters. So I can write 1 divided by 15 is equal to y2 divided by 13. 1 divided by 15 is equal to y2 divided by 13, or y2 is equal to 0.867, this ordinate. Next, RB is equal to this load into this ordinate plus 70 into 1. So 100 into 0.867 plus 70 into 1. So this gives me the value 156.7 kilonewtons. Now compare both the values, whichever is maximum, that is absolute maximum shear force. Absolute maximum shear force is equal to 160.69 kilonewtons. Second step, influence line diagram for shear force at section x is equal to 5 for shear force. Let this be the beam. This is the point. X is equal to 5. L minus x is equal to 10. Now draw the standard shear force diagram. So standard shear force diagram is like this. Now write the values. X is equal to 5. L minus x is equal to 10. Now here loads, they are acting to the right side. It means one load is here, second load is here. 70 is at the front, 100 is at the back. Let this ordinate be y1. Second, loads are to the left. So 70 front load is here, 100 kilonewtons load is here. Now mark the distances. So this distance from here till here, it is 2. This distance is 2. Now this ordinate is given by value x by L. So x is 5, L is 15. 5 by 15, it gives a value 0.33. This ordinate is L minus x by L. So L minus x is 10. 10 divided by 15, 0.67. So these are the ordinates. Let this ordinate be y1, this ordinate be y2. I have to calculate y1 and y2. Now consider this triangle. 0.67 divided by 10 is equal to y1 divided by this distance is 8. So I can write 0.67 divided by 10 is equal to y1 divided by 8, or y1 is equal to 0.536. Now consider this smaller triangle. 0.33 divided by 5 is equal to y2 divided by, from here to here, this distance is 3. Overall is 5, this is 2, this is 3. So I can write 0.33 divided by 5 is equal to y2 divided by 3, or y2 is equal to 0.20. Next, write the equation. Maximum negative shear force, it occurs at this point. This load into this ordinate plus this load into this ordinate is equal to 70 into 0.33 plus 100 into 0.2. So you have the answer 43.10 kilonewton. This is the negative shear force. Maximum positive shear force, this 100 into this ordinate, 100 into 0.67 plus 70 into y1. So y1 is 0.536 is equal to 100 into 0.67 plus 70 into 0.536. So you have the answer 104.52 kilonewtons. Third step, maximum bending moment at section x is equal to 5. Now arrange the loads as required section. Now a question comes, how to arrange the loads. Say this is my beam and this is my required section. Say this distance is x is equal to 5 and this is L minus x is equal to 10. Now there are two loads. Which load to put here? Now to get maximum bending moment, always put the bigger load at the required section. Put the bigger load at the required section. So draw standard bending moment diagram. So this is standard bending moment diagram. This value. Now put the bigger load. If the two loads are different, here 170, so put 100 load exactly at the required point and 70 load wherever it comes. So let this ordinate be y. Now this ordinate is given by equation x L minus x by L. So x is 5, L minus x is 10 divided by 15. So you have the answer 3.33. Now here when you look at this section, so this distance is x is equal to 5, L minus x is equal to 10. This distance is 2. First I have to determine this ordinate y. So I can write 3.33 divided by 10 is equal to y divided by this value is 8. So 3.33 divided by 10 is equal to y divided by 8, or y is equal to 2.66. Now find out loads. 100 into this ordinate plus 70 into this ordinate. So bending moment at x is equal to 100 into 3.33 plus 70 into 2.66. So maximum bending moment value you are having 519.2 kilonewton meters. This is the maximum bending moment value. So this completes the 2-point problem. Thank you.